Hello and welcome to some Unit 4, factoring. Okay, this whole unit's going to be factoring and finding roots of polynomials. So here's a little flow chart to start us off. What do we do, okay, to factor? First thing you should do, always, as that's the first bubble, is find the greatest common factor. Okay, what do they all have in common? All right, from there, if you've already done that or you can't do that, you need to decide based on 2 terms, 3 terms, or 4 terms. So if you have 2 terms, okay, you can look for some patterns in there. If you've already taken the GCF out, are there squares, are they cubes, for example? If you have 3 terms, okay, that's when it's more of the traditional factoring that you might have seen before or you're used to. Okay, you can split into 2 binomials by guessing and checking, or you can do the split the middle method. If it's a little bit harder. If you have 4 terms, you can factor by grouping, which is one of the only ways you can do it by just straight factoring. Okay, so what to do with 2, 3, and 4 terms, little flow chart, kind of to help you stay organized and pick strategies. Okay, a little bit of vocab before we jump into it. GCF, you've already heard me say greatest common factor. Okay, but what does that mean? That's just the largest number, or I should say the largest number or variable that you can pull out of each term. The largest number and variable or variable that you can pull out of each term. Okay, that's greatest common factor. GCF is greatest common factor. The factor theorem, I'm going to switch colors here. The factor theorem is going to sound a little bit mathy, but it should make a whole lot of sense. All right. X minus k, so don't get lost in all the mathy stuff yet. X minus k is a factor of f of x. So x minus k is a factor of some polynomial, f of x, if when you plug in k to f of x, you get 0. Okay, so x minus some number will be a factor of a function if when you plug in that number, whatever it is, you get out 0. Okay, that is a 0. That's the point of a factor. You plug it in, that's the point of factoring. We're trying to find what numbers make our equation 0. Okay, so x minus k is a factor of f of x if when you plug in that k, you get out 0. All right, so let's try some examples. All right, 4x squared minus 108x. Okay, it says when factoring, always look for the greatest common factor, the GCF, first. So the first thing I want to do is look for that greatest common factor, the thing that they both have in common. Well, they both have an x in common. Okay, so x is going to be part of the greatest common factor. And they both have a 4 in common, so I take a 4 out. All right. I know the 4 goes into 4. I know 4 goes into 108. Okay. So they both have a 4 in common. If I take a 4x out of 4x squared, well, the 4 is gone, so there's no numbers left. If I take x out of x squared, I'm left with just an x. Okay. Minus, if I take 4 out of 108, well, 108 divided by 4 is 27. You can use a calculator for that. That's what I did. So 108, 4 times 27 is 108. Okay, so if I take a 4 out of 108, I'm left with 27. And I took the x and pulled it out front. Okay, and there we go. All I did was I took the GCF and pulled it out front for both. Okay, it's kind of like the opposite of the distributive property. I'm taking out something instead of distributing it to both. I'm taking it away from both. Taking it out of both is a better way to say it. All right, let's look at B. 125 d squared minus 50. If I take out, what's the biggest factor they have in common? The greatest common factor. Okay, you might be, go ahead and hit pause and give it a try if you want. You might be thinking that 5 is the biggest factor here. 5 goes into both. It does, but I think we can get a bigger number. I think 25 goes into both 125 and 50. So So 25. Okay, I can take out of both. I can't take a d out of both because the first one has d squared. The second one doesn't have a d at all. It's just 50. So that d is not part of the greatest common factor this time. So if I take 25 out of the first term, I'm left with 125 divided by 25 is 5d squared. Take 25 out of the second term. Dividing it out, I'm left with 2. 25 times 2 is 50. The next one, C. What do all those things have in common? You should be able to look at it and pick it out right away. You said x, good job. I take an x out of each. I have to take x out of x cubed, I'm left with x squared. If I take an x out of x squared, I'm left with just x. If I take an x out of x, I'm not left with 0. And it can't divide and get 0. So if I take a divide an x out of x, I'm just left with a plus 1. There we go. Right, so we're just taking the biggest common factor out of these. And then for part D, what do those have in common? Go ahead and try that on your own. Hit pause right now. When you let go of pause, or when you hit play again, you're going to see the answer. All right, greatest common factor is 3. 3 times 4 is 12. 3 times 5 is 15. No x's in the first term, so we can't include an x in our greatest common factor. Slide up. This says factor by GCF and grouping. Okay, grouping is a little bit trickier. Okay, so let's look at that first one. X cubed plus 2x squared minus 9x minus 18. First thing I should ask myself, think back to the flow chart. What should I do? Correct. Is there a greatest common factor? No. Okay, 18 doesn't have an x, so I can't include x. And the first one's just an x cubed, so there's no numbers that's shared between them all, other than 1, which doesn't help us. So nope, can't take greatest common factor up. So we got to factor 4 terms. If you look at your flow chart, it says when you have 4 terms, you factor by grouping. So let's do that. All right, and this is going to take a little long to do the first one, just so that we can explain it all. But the first thing I do is I'm going to split this right down the middle. Okay, I'm going to take, not a very straight line, but I'm going to take 2 terms on one side, 2 terms on the other side, including that negative sign is going to go to the right. All right, and then I'm going to say, what is there anything that x cubed plus 2x squared have in common? Anything that x cubed plus 2x squared have in common? All right, you might be thinking, yeah, well, they have an x in common. They sure do. In fact, they have an x squared in common. Okay, so I can take an x squared out of each of them. And then I'm left with an x plus 2. Now I got to do it for the other side. Let's switch to green, I think, for this one. I got to go, well, what do negative 9x minus 18 have in common? I see a 9, yep. In fact, I see a negative 9. Anytime you can take a negative out of both, do it. Okay, let's get a negative out of there. So negative 9 out of the first one. Negative 9 out of 9x is just x. Take negative 9 out of 9x. Excuse me, if they take a negative 9 out of negative 9x, I'm left with just an x. Take a negative 9 out of negative 18, I'm left with just a positive 2. Okay, negative got distributed out, or reverse distributed out. All right, this is where it kind of gets tricky. Okay, notice we have the exact same thing here. That will be true every time you group. If you factor by grouping and you do it right, okay, you should get an x plus 2 there every time. All right? Or, excuse me, the same thing left over every time. Now it's like grouping again. Okay, what does, or pulling common factor out again. What does the first term have in common with the second term? Okay, what does this blue have in common with this blue? Well, they both have an x plus 2. So x plus 2, okay, they both had that in common, gets pulled out, which leaves me with just an x squared and negative 9. Okay, so there's my answer. Full answer is x plus 2 times x squared minus 9. All right, I grouped both of them. All right, this problem can actually be factored further, but we'll learn about that in a later lesson. Let's look at the next one. All right, what do those 4 terms, well, there's 4 terms first, okay, which means based on our flow chart from the very first page of the notes, the very top of this video, I got to factor. Okay, so I factor by grouping. So I'm going to first always, is there something that can be pulled out of all 4 terms? Because if there is, okay, that is going to help me out later. I don't think so. They don't all have an x. Okay. The first 3 have a 2, but the 25 doesn't have a 2. 5, no, 5 doesn't go to 4 or 8, so it doesn't look like it. Okay. So let's split down the middle again. All right, my first one, let's go red again, keep the color scheme the same. Ax cubed minus 4x squared. What do ax cubed and negative 4x squared have in common? Well, they have an x squared in common, so that's going to be part of it. And it looks like they both have a 4. They don't both have a negative 4, but they both have a 4 for sure. So I'm going to pull 4 out. Okay, 4 goes into 8 and 4 goes into 4. That leaves me with, well, 4 goes into 8 twice. X cubed goes in, if I take an x squared out of x cubed, it leaves me with an x. Minus 4 goes into 4 once. And if I take an x squared out of x squared, I don't have any left, I just have a 1. All right. Switch over to green, do the right side. Well, those things have a, I'm going to pull the negative out. I know they both don't have it, but because it's on the first term, I think it'll make the rest of the problem easier. So I'll say they both have a negative 25 in there. I'm going to pull a negative 25 out. If I pull a negative 25 out of negative 50, I'm left with just a 2. Okay. And then the x is still there because I didn't pull an x out. Then if I pull a negative 25 out of 25, I'm left with a minus 1. Okay. So I always like it better if there's no negative on the first term. That's just my preference. And also, that works out because you should have noticed that these two things are exactly the same. And when you factor by grouping, it should be the same. Okay. After you factor the first, if you factor once, greatest common factor out of both sides, you should be left with the same thing. And we do, underlined in blue, they're both 2x minus 1. So take those out, pull that out in front. Essentially, it's like a greatest common factor again. What do those 2 huge terms have in common? Well, the red term and the green term have 2x minus 1 in common. So I'm going to pull that 2x minus 1 out. If I pull the 2x minus 1 out of the red, I'm left with 4x squared. If I pull the 2x minus 1 out of the green, I'm left with negative 25. And I'm done. Factor by grouping. Okay. Again, this one can be factored further. We don't know how to do it yet, so we'll learn that in a second. Or, excuse me, in a future lesson. All right. I want you to try example 4 on your own right now. When you come back, I'll walk you through it. Hit pause now. Otherwise, I'm going to keep going. First things first, do they have anything in common, all 4 terms? If I'm going to factor, I got to look at that first. 3, no. X squared doesn't have a 3. X, no, 9 doesn't have an X. So, no. Let's go ahead and split it into our red and our green. Okay, what does the red have in common? What do those 2 terms in red have in common? you should have seen that they have x's in common. How many? Well, x squared. If I take an x squared out of the first term, I should be left with a 3x. If I take an x squared out of the second term, well, that's all of it. So there's just a 1 left over to hold that place. 10, that's a plus sign. Okay. All right, next one. I have negative in both. I'm going to take a negative out for sure. So negative 27x minus 9. I'll definitely bring a negative out. If I pull a negative out what do they have in common? I still need something else for them to have in common. I'm guessing 9. 9 goes in 9, yep. 9 goes in 27, yes. No x, so take a negative 9 out of both. Okay, if I take a negative 9 out of 27x, I'm left with 3x. Oh, that's good. If I look over here, that's good. If I take a negative 9 out of negative 9, I'm left with just a positive 1. All right, what should you be checking right now? Absolutely, you should be checking to see if these two things are the same. Are they the same? Perfect, we grouped correctly. Factor by grouping works for this one. So I'm going to pull that factor out of both terms. If I pull a 3x plus 1 out of the red, I'm left with an x squared. If I pull 3x plus 1 out of the green, I'm left with a negative 9. And there we go.